Hi everyone. In today's presentation, we will be looking at Chapter 6.1, Greatest Common Factor and Factor by Grouping in the OpenStax Intermediate Algebra textbook. And more specifically, we will be looking at the first learning objective, find the greatest common factor of two or more expressions. Now, how you can find this particular chapter in the textbook, you'd first come to the OpenStax platform. You're looking for the Intermediate Algebra textbook itself. And then on the left-hand side panel, you have your table of contents. Scroll down to Chapter 6.1, Greatest Common Factor and Factor by Grouping. And then within this particular chapter, we're looking again at the first learning objective, the first section, find the greatest common factor of two or more expressions. If you scroll down in the textbook, this is this section right here. Goes through a few different items and examples. And then if you scroll all the way to the bottom of the chapter, you can find the section 6.1 exercises. And this is the first section. So this video is covering these first 8 questions in particular. All right, so let's go ahead and get started from there. Let's first take a look at what is a factor. So a factor is something that is multiplied to make a product. As an example, let's say we have the statement 4 times 6 equals 24. To define what each of these different numbers are here, we have 4 and 6. Each of these are considered to be factors then of the number 24. The number 24 then is what's called a product. It's the answer to a multiplication fact. Other examples of this include 2 times 12. These two numbers are then factors of 24 as well. So these are factors. Now, when we factor, we are breaking something apart, the number 24, into pieces, 2 and 12 and 4 and 6, that multiply back together here. Another important concept for this chapter is what is a prime number? So a prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself. So examples of this include numbers like 2, which can only be factored into 1 times 2, 3, which is 1 and 3, 5, 1 times 5, 7, 1 times 7, and 11. These are the first initial prime numbers here. Things that are not prime, they're called composite numbers, include things like the number 4. So if you look at the number 4 can be 1 times 4, that's true, but it can also be 2 times 2. This means that 4 actually has 3 factors, 1, 2, and 4. So these are not prime. 4 is not prime. It is considered composite. So we've looked at factors and we defined a prime number. Now let's look at what is prime factorization. So prime factorization is defined as breaking a number into prime number factors. Prime numbers are the basic building blocks of every single number. So prime factorization is basically breaking them down into those basic building blocks. Let's take an example here. So let's say we have the number 36, and we want to break 36 into prime number factors. Well, one method of doing this is using what's called a factor tree. Now, there are multiple ways that you could break down this number using a factor tree. Let's say we started with the smallest of the prime numbers, which would be 2. So what we would have here is we could break down 36 into 2 and 18. Now, 2 is a prime number, so if I use the mechanic of circling the prime number, that would be the leaf of it. And then 18 can be further broken down into 2 and 9. Again, circle 2, and then 9 can be broken down into 3 and 3 here. So 36 then, the prime factorization of 36 would be 2 times 2 times 3 times 3. Now, why this is useful for this concept is because we can use prime factorization to then figure out what the greatest common factor is. So, what is the greatest common factor? The greatest common factor, or GCF, is the largest factor shared by two or more numbers or expressions. For example, let's say we are asked to find the greatest common factor of the numbers 24 and 36. How we could do this is we could first break down the factors of 24 using prime factorization to figure out what these numbers would be. Now, let's first, though, define what the actual factors are of 24 and 36, and then we'll look at how to find it using prime factorization. So first off, the factors of 24 are going to be 1, 2, 3, 4, 6, 8, 12, and 24. In other words, 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, and 4 times 6 is 24. If I was to then look at the factors of 36, the factors of 36 include 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay? Now, the largest common factor these two numbers share is the number 12. So this would be considered the greatest common factor of 36 and 24. Now, other common factors are 2 and 2 is shared, 3 and 3 is shared, 4 and 4 is shared, and 6 and 6 are shared. But none of these are the greatest common factor, which is 12. So we would say the GCF of 24 and 36 is equal to 12. Now, one of the important methods or mechanics to actually find the greatest common factor for numbers is using something called prime factorization again. So we're going to break down the numbers 24 and 36 using prime factorization. So step 1 is to factor each number into prime numbers. So again, I like to use a factor tree to actually do this type of method. So we can start with the number 24, and 24 then breaks down into 2 and 12. 12 then can break down into 2 and 6. So I'm starting with the smallest of the prime numbers. And then 6 can be broken down into 2 and 3. Okay. 36 then can be broken down into 2 and 18. Again, if I start with the smallest one. Don't have to, by the way. You could start with other numbers. So 2 and 18. Then we can have 3 and 6. And then 6 can be broken down into 2 and 3. Or I could say 2 and 9, I guess, for 18. But then we have 2, 3, 2, and 3. So what we're going to do now is step 2, list all the factors matching common factors in a column. In each column, circle the common factors. So if I had 24, and I listed this in a column, let's start with the smallest ones and go bigger. So we have 2 times 2 times 2 times 3. Okay, so these are common factors then of 24. Or I should say the prime factors of 24, not common. 36 then include 2 times another 2, times a 3. So there is 36 doesn't match up to this 2, but it does match up to the next 3. And then it has another 3. So what we're doing here is we're matching similar prime numbers. So they have this column is shared, this column is shared, this column is not, this 2 doesn't match, and this column is shared, while this 3 is not. So what we're going to do now is we're going to bring down the common factors the numbers share. So this 2 and this 2 are shared, this 2 and this 2 are shared. This 2 is not, so can't bring it down, but I can bring down this 3. So now we have 2 times 2 times 3. Step 4 is to multiply those factors. 2 times 2 is 4. 4 times 3 is 12. So this confirms what we showed in the previous slide, that the greatest common factor is 12. So we will be using this method of finding the greatest common factor using prime factorization to help us with the more complex problems now that we're going to look at when we're trying to break down the greatest common factor within polynomials, essentially. So now what we're going to be doing is we're moving from numbers, 24 and 36, to expressions. So first off, this is what's called a polynomial. So in algebra, expressions may include numbers and variables. This expression here then, we have 18. 18 is called a coefficient, and we have a variable part, x to the third power. Another example of this would be 15x squared, where the coefficient here is 15. So coefficient is 15, and our variable part is x squared. So it's important to understand these two differences between the coefficient, 18 and 15, and the variable part, x third to x squared. Another core understanding here is that you can expand variables with exponents and find the greatest common factor between these. So for example, if I expand the variables with exponents and find the greatest common factor of x to the fourth power and x to the second power, what we have here is really x times x times x times x. X squared then is x times x. So then if I looked at, okay, what do they actually share? What is the greatest common factor for these? We would say this column and this column match up, and this column and this column match up. So the common variable factor, or greatest common factor for x to the fourth power and x to the second power, is really x times x, or x squared. Now, an easy shortcut here is when finding the greatest common factor for variables and exponents, you can use the smallest exponent of the shared variable, which is our x squared here. So that's kind of a shortcut for understanding here. Okay, so let's go ahead and get into the core concept of this chapter now and the learning objective 1. So we are now finding the greatest common factor of two expressions. The first question I have then here is 18x to the third power and 30x squared here to the second power. So our steps are to first, step 1, factor each coefficient, the coefficient in this case being 18 and 30, into primes, and then write all variables with exponents, x to the third power and x squared, in expanded form. So first off, let's break down 18 and 30 into its prime number form. So again, I'll go ahead and use a factor tree here. So we have 18, which I can break down into 2 and 9. And then 9 can be broken down into 3 and 3. And then 30 can be broken down into 2 and 15. And 3 and 5. So if I then go to this first expression, 18x to the third power, what I could write this as is 2 times 3 times 3. That is the coefficient part. And then I can do the variable part, x to the third power, as x times x times x. So I've expanded that out now. Then we can do that for the number 30x squared. Which is going to be 2 times 3 times 5 times x times x. Step 2 is to list all the factors, which we just did, matching common factors in a column. In each column, circle the common factors here. So 2 and 2 match up. 3 and 3 match up. 3 and 5 do not. And then we have this x term and this x term that match, while this x term does not. So step 3, bring down the common factors that all expressions share. Well, we have 2 times 3 times x times x. Then step 4, multiply the factors. So we're going to multiply 2 times 3. These are the two whole numbers we can multiply. And then x times x, which is x squared. And that is our answer for question number 1. Let's now go to question number 2. So we have 12a to the 4th power and b to the 2nd power, and 18a to the 3rd power and b to the 5th power. We're going to factor each coefficient into primes and write all variables with exponents in expanded form. So first off, you can factor 12 and 18 using prime factorization. Let's go ahead now and assume that we understand this process of prime factorization. So I'm going to now break this apart into its factor list here. So 12 can break apart now into 2 times 2 times 3. So that is 12. 2 times 2 is 4. 4 times 3 is 12. And then we have our a to the 4th power, which is a times a times a times a. And then we have b squared, b times b. Now, eventually you won't necessarily have to list all these out. You could compare the common ones and then choose the variable that's smaller. So that's eventually we're getting to that point. But for the time being, let's go ahead and list them all out in expanded form. So 18 then, a to the 3rd power and b to the 5th power. 18 is going to be 2 times 3 times 3. So 2 times 3 is 6, 6 times 3 is 18. And then we have 3 a's, a times a times a, and 5 b's. So hopefully I have enough room here. B times b times b times b times b. Okay, so now we have this all expanded out. Step 2 is to list out our factors, which we did, and match the common factors in a column. In each column, circle the common factors. So in this case, what we basically have here is we have the 2 and the 2, that matches up. This 2 does not match up to the 3, but we have this 3 and this 3 that match up. So I'll do different colors for each. So this 3 and this 3. This 3 then is uncovered. There's no 3 that matches up to 12. So basically 12 and 18 shares a greatest common factor of 6. Then let's circle the common variable. So we have an a term and an a term, another a term and another a term, and an a term and an a term. This 4th a term, though, does not match up. So that's uncovered. And then we have the b terms, so I have a b and a b, and another b, and another b. There are no more b's up here, so that's all I have. Okay, so now we've circled everything that we can. So let's bring down the common factors that all expressions share. So we have the 2 times our 3. So 2 and 2, 3 and 3. And then we have the 3a's, right? So times a, times a, times a. And then we have the b's. So times b, times b. Now we can multiply our factors. So 2 times 3 is 6. A times a times a is a to the third power. And b times b is b to the second power. So the greatest common factor of this problem is going to be 6a to the third power and b squared, or b to the second power. Question 3 then has 3 separate terms here. So that's interesting. We have 20m to the fourth power, 35m to the third power, and 25m to the second power. Step 1 is to factor each coefficient into primes, and then write all variables with exponents in expanded form. So let's start with the first one here. We have, let me go ahead and draw this out too. So we have 20m to the fourth power. So this is going to be 2 times 2 times 5. 2 times 2 is 4. 4 times 5 is 20. So that's the number part. And then we have 4 m's. So m times m times m times m. Okay, m to the fourth power. What about 35 m to the third power? Okay, so 35 is going to be 5 times 7 here. Okay, so 5 times 7 is 35, and then we have 3 m's times m times m times m. And then finally, we have 25m to the second power, which is 5 times 5 is 25, and then 2 m's, m times m, that's m squared. Okay, so we've now listed out all our factors. We need to then find what our common factors are. Now, what's interesting about this, common means they have to appear in all the lists, right? So it can't just appear in 2 of them. So if I first look at 20, it has 2 and 2. Well, 2 does not appear in 35 and 25. So there are no 2's that you're going to bring down. I do see a number 5 though. There is one 5 that appears here, here, and here. So I'm going to circle this first 5 here. Now I'm only going to circle one of the 5's because this other 5 that's in 25 is not covered in the other 2 ones, right? I then also have a number 7. Number 7 does not appear in these lists, so I also need to leave that uncircled. Then I have my m's. So I have an m that appears here, here, and here. That's one m. And then I have another m that appears here, here, and here. But that is the last m that appears in the 25m squared. So I cannot circle the other m's here. That's also why we basically would choose the smallest of those m variables, m to the second power. Okay? From here then, we're going to bring down the common factors that all expressions share. So all expressions share a 5. So 5. All expressions shares one of the m's, and all expressions shares another m. But none of the other m's are covered. Step 4 then is to multiply the factors. Well, I now have 5 times m times n. Well, 5 is the number. There's no other number that I'm multiplying by. And then the 2 m's would be labeled as m squared here. So my answer for this, the greatest common factor, is 5m squared. The final question I have in this learning objective is to find the greatest common factor of 24a to the 5th power, b to the 3rd power, The second term then is 36a to the third power and b to the sixth power. And then finally, 60a to the fourth power and b to the second power. So definitely a hairy looking question with a lot of different terms here, but the basic process is actually the same here. So let's go ahead and first break up 24a to the fifth power, b to the third power here. So 24 first is going to be defined as 2 times 2 is 4, times another 2, which is 8, times 3, which is 24. So those are the primes here. Then I have 5 a's, so a times a times a times a times a. Again, I'm kind of doing this out expanded, a little bit tedious. Eventually you can just take the smallest of the terms, but I want to make sure that we see that expanded out. And then we have b times b times b. So b to the third power here. So that's the first term. Then we have 36 a to the third power, b to the sixth power here. Well, 36 can then be broken down into 2 times 2, which is 4, times 3, which is 8, or excuse me, 2 times 2 is 4, times 3, which is 12, and then times 3, which is 36. Sorry about that. And then we have a to the third power, which is a times a times a, and then b to the sixth power, b times b times b times b times b, and one final b that we have here, okay? And then the last term we have is 60 a to the fourth power, b to the second power. So we first have 2 times 2 is 4, times 3 is 12, times 5 is 60. Then we have 4 a's, so a times a times a times a, and we have 2 b's, b times b. All right, so now we've expanded out, we've listed all our factors, we now need to match them up. So let's start first off with our number 2. So I see 1, 2 that appears in all the lists. So 2, 2, and 2. That's 1, 2. I then see a second 2, right? So I see a 2 here, a 2 here, and a 2 here. Remember, the number has to appear in all lists. I then have a third 2, but do you notice how this third 2 is not matched up with 36 and 60? There's no third 2, so that 2 is uncovered. Next, I go over to the 3's. So in this case, I do see a 3 that's covered. 3 here, 3 here, 3 here. I have an additional 3 in 36, but that's not covered in 24 and 60. And I also see a 5 in 60, but there's no 5 in 24 and 36. So the number part is 2 times 2 times 3. Then we go to the variable part. Again, there is a shortcut for the variable part in that you're taking the smallest ones of each, but let's say we are first looking at the letters. So notice how a to the third power, there's the smallest amount of those a's here. So in other words, these 3 a's are going to be covered by these 3 a's and these 3 a's. The other a's, this fourth a here and these other 2 a's, the 5 in total here, are not covered. So they're eliminated. In other words, a to the third power, that's the smallest of the exponents. That's what then flows down to the next part. The b's are the same. If I look at the smallest of the b's, I have, and here, b to the second power, there are 2 b's that are covered in each. So these 2 b's, these 2 b's, and these 2 b's. All of the other b's are not covered. They do not drop down. So step 3, bring down the common factors that all expressions share. Well, they share 2 and 2. So 2 times 2. And there is another 3, so times 3. I then have 3 a's, a times a times a, and 2 b's, b times b. So multiplying these factors, 2 times 2 is 4, 4 times 3 is 12. A to the third power then, a times 8, 3a's, a to the third power, and 2 b's, b to the second power. So this is considered to be my greatest common factor for these problems here, or for these three terms. So to clarify this greatest common factor shortcut that I've been talking about, to find the greatest common factor, once you understand the full process, you can use this particular shortcut, which is to find the GCF of the coefficients, which we've been doing, and then keep only variables that appear in every expression, and then use the smallest exponent for each of the variables here. So for example, if I have, let's say I have this expression, 16x to the fifth power and y to the third power, and then I have 24x to the second power and y to the fourth power, I'm going to use the greatest common factor of 16 and 24, which in this case is 8. And then I'm going to use the smallest of the shared variables. Well, the smallest of x to the fifth power and x to the second power, well, that's just x to the second power. And then the smallest of y to the third power and y to the fourth power, well, that's y to the third power. So my answer in this case is to have the greatest common factor of x to the second power and y to the third power. The biggest shortcut really is, instead of having to list out all the letters, that you just take the smallest of the variables, right? That's very useful when you're trying to increase your speed here. All right, so that concludes my presentation. There are these 4 practice questions that you can find in the guided notes for this presentation, which you can find in the description of this video. Each of these different questions then also has an answer key tied to it within the guided notes. So feel free to take a shot at each of these questions here, and then you can check the answer key to see if you're on the right track. If you have any questions, feel free to plop those questions in the video comments below. Thanks everyone, and we'll chat in the next video.